right, today we're going to talk about compound inequalities. That's lesson 3.6. Your learning target just specifically for today, you're going to be able to graph compound inequalities. We're not going to write today, we're not going to solve. Today we're just going to start out with graphing compound inequalities. So in order to achieve that target, you need to know what is a compound inequality? Well, I'm going to try to scaffold my knowledge, so I look at the word compound. If I think about a compound word, it means more than one word, like dog house, tailgate. What's another compound word? Bathtub. Okay, those are all compound words. There's more than one. So compound I know means more than one. So then I can take that and think, well, a compound inequality then would mean more than one inequality. And that's exactly what it is. A compound inequality is two inequalities that are joined by the words and or. So you have two words that join a compound inequality that connect them. It's either going to be an and statement or an or statement. Here are some examples. Ors have two separates. So ors are separated. Two separate inequalities. You have x is bigger than 3 or x is less than 2. And is connected or smushed in between. So I'm going to say stuck in middle. That's what an and is. So this is saying -4 is less than x, which is less than 5. The or statement says x is bigger than 3 or x is less than -2. It's separate situations. It's just, you can't happen at the same time. It's like if your family gave you a choice to do something. Like you can have milk or water. You can have milk or water, but not both. Or you can have money for your birthday, or you can have concert tickets. Which one are you going to choose? You can't have them both. So it's you either choose this or this. There is no connection with an or statement. An and statement means you can have a connection. Like you can have money and you can go to a concert. If your parents say you can have money and go to a concert, that's connected. That's not separated. Or you can have coffee and a movie. Another thing that's connected, you can have coffee, then a movie. You don't have to choose to only do one. Or is separate, and are together, connected together. So I want to show you a couple examples of what the graphs will look like. These are what graphs look like for ors and compounds. Notice that I'm going two separate directions. I'm getting smaller than, and I'm getting bigger than. Separate directions means an or statement. The next example, it looks like I have a colored in line, an open, and they're connected. When they're connected, it's an and statement. Or is separate, you're going in opposite directions, and is connected. Okay, the next one, I have a circle, I have a circle, it looks like they're connected, that's an and graph. So or graphs look like this. You're going in opposite ways, and graphs look like this. There's just a line connecting the two circles. So or is separate direction and is connected. Or separate and connected. Again, your learning target today is that you can graph compound inequalities. So you need to know, how do you graph? So you have two different compounds. You have an or compound and an and compound. An or compound, this is the process. You graph each inequality separate. That's what you're going to do. It looks like this. X is less than a number or bigger than a number. It's going to go in opposite directions. Okay? And this is how we do it. So we make a circle at each number, and then you're going to connect them. So I want you to box off, connect them. That's what you're going to do. The or, you just graph them each separate, and you make a circle and connect. An or statement has two different situations going on, and it's stuck in the middle. Let's see, I think I have here, will be connected. So let's just draw on a rough number line what an or is going to look like. We'll go opposite. An and on a number line will be connected. Or's opposite and is connected. Okay, so we're going to graph this one. This is an or statement, so that means I'm going to graph each one separate. So x is less than -2. I'm going to make a circle at -2, go to the left. Or, so I did that one, x is bigger than or equal to 0. A colored in circle at 0, going to the right. And now I'm just double checking. Or, does it look like this? And it does. So I'm good. This next one is an and graph. So I know that it's going to look like the following. X is stuck in the middle. So I'm going to make a circle at -8 and a circle at 4. So -8, I have a circle that's colored in because there's a line. 4, I have a circle. And now I connect them. So now I just connect them. And I just double check. It sure looks like an and to me. Okay, the next one, I have another or statement. So or graphs, just double checking. They go in opposite directions, so they're not connected. So I have x is less than or equal to 0. I make a colored in circle at 0 going to the left. Or x is bigger than or equal to 9. A colored in circle at 9 going to the right. This is another and graph, this last one. And graphs I know look like this. They should be connected. So I'm going to make a circle at -6. I'm going to make a circle at 3. And I'm going to connect them. And that's our learning target for today. So my question for you, do you feel like you would be able to graph a compound inequality? Do you know what an or graph looks like? Do you know what an and graph looks like? Do you know what an or graph looks like in symbolic form? That means when x is smushed in between, like I'm showing here, you have a number is smaller than x, which is smaller than a number. Do you feel like you would be able to know, hey, that's going to look like an and graph. X is in between those. So you could think of the boxes or the numbers as the circles, and then X is between them. So between them means color it in between them. And that's our learning target for today. All you're going to have to do is graph a bunch of different compounds.